This is Bud Lopez with New Mexico State University Tribal Extension. Mikkel had asked me if I would be willing to help out with a couple of these programs over the next couple of months, and I said I'd be glad to. I had already set this one up for our personal for our own extension programs this last gardening series, so it's all set and ready to go. I'm going to be talking about integrated pest management. She mentioned that they were wanting to do more on I guess organic growing or natural growing, and integrated pest management, although it does not exclude chemical control, it highlights and emphasizes the more cultural control, prevention, sanitation, and that type of thing that does not involve chemical application or the use of any toxic chemicals. You can do most of it without that, and that's what we tend to emphasize and use. I worked for many years on native plant propagation and restoration projects, and our mitigation required rules required that we grow as organically as possible. Growing organically or organically grown, I have a little bit of an issue with the nomenclature on that, because in my mind, anything that's ever been involved in cell division is organic. But non-synthetically enhanced growing methods is kind of what I like to think of it as. So anyway, let's get started. We're going to start with just a definition. IPM, Integrated Pest Management, an effective, environmentally sensitive approach to pest management that relies on a combination of common sense practices, IPM programs. Am I having interference with my screen from pop-ups?
No, I see.
Okay.
What is IPM?
Okay, gotcha. All right. Combination of common sense practices. IPM programs use current, comprehensive information on the life cycles of pests and their interaction with the environment. This information, in combination with available pest control methods, is used to manage pest damage by the most economical means and with the least possible hazard to people, property, or the environment, which is our goal in growing organically, if I'm not mistaken. IPM takes advantage of all appropriate pest management options, including but not limited to the judicious use of pesticides. How do you implement it? IPM is not one single method. It requires a whole plan. You have to start from before you even decide what you're going to grow. You've got to start in your planning, in evaluating decisions, control, and your controls. In practicing IPM, growers who are aware of the potential for pest infestation follow a four-tiered approach. They include set action thresholds, and I'm going to go through these all individually and kind of explain the idea behind them and how they can affect your success. Monitor and identify pests, prevention, and then control. Okay, action thresholds. This is where you set your threshold of damage or impact that your pest is putting on your crop that you can allow up to before you take action. So in other words, a couple of spotted leaves, the loss of 1% or 5% of your crop to the pest, you won't do anything. You'll just monitor it and do other control issues to prevent it or for it from expanding. Now, your threshold, above your threshold, is where you're going to decide, well, it's time, I need to do something a little more drastic, whether it's more cultural control or more intense labor or whatever the case may be. And again, it's the economic threat that you're looking at is where you set your threshold. Prevention is the first line of defense. IPM programs work to manage the crop to prevent pests from becoming a threat. In an agriculture crop, this involves cultural methods such as rotation, rotating between different crops in different seasons. There's certain pathogens that exist in the soil that require a specific host in order to perpetuate from season to season and over time. So, for instance, if you grow one crop and it develops one of those pests or pathogens in the soil. If you change to something else that's not susceptible to that pathogen over a few seasons, another crop will allow that pathogen to expire because it doesn't have a host to live on. And then you can you can bring that susceptible plant back into that particular field or spot in your garden. There's also pest-resistant varieties that I worked in hybridizing for a seed company for many years, and we weren't at this point. I was working with ornamental plant material. At this point, we were not looking particularly at new colors or shapes or sizes of individual species. We were looking for old tried and true species that have resistance to pathogens that they were susceptible to. So that's where even in the seed industry and the breeding industry, the trend is to move towards resistant plant material. In that case, that would help to avoid the use of chemicals in the long run, obviously. And then planting and then rootstock. If you're doing grafted plant material like fruit trees and that kind of thing, there's a lot of good resistant rootstock out there that isn't on the actual. For instance, if you're doing a Gala apple, it may not have a very strong root system, so you graft it onto a stronger root system that could possibly have resistance to disease that typical Gala apple might have. They're working with now. I don't know if any of you are familiar with Reagan Watsalusi. We're working with her, helping her get the heritage peaches going and getting that community reestablished in orchards that went away with the intervention of the Anglos, in particular Kit Carson. She's found some remnant trees all over the reservation, and she's got some going, and so we're working on that. I'm helping her as much as I can to get some going, and she also has been approached by companies that are growing market peaches, because apparently that rootstock, or obviously that rootstock, is very, very strong, drought resistant, drought tolerant, and pretty disease free. So they're hoping to use that rootstock for their varietal peaches. So anyway, that's one way to do it. These control methods can be very effective and cost efficient to present little or no risk to people in the environment. Control. Finally, you reach your threshold and then you're going into your control. Once monitoring, identification, and action, thresholds indicate that pest control is required and preventative methods are no longer effective. Let me go back. I missed this one. Monitor and identifying pests. I thought I was out of order here. Not all insects, weeds, and other living organisms require control. Many organisms are innocuous and some even beneficial. IPM programs work to monitor for pests and identify them accurately so that appropriate control decisions can be made in conjunction with action thresholds. These monitoring and identification This monitoring and identification removes the possibility that pesticides will be used when they are not really needed, or that the wrong kind of pesticide will be used. For instance, if you're going to go out there and use a malathion or something like that for your insect population, remember you're taking out the good ones with the bad ones. So you want to be able to decide the population that is out there in what proportion of good and bad before you make that drastic move of using the chemical control. We talked about prevention and then control. We're down back to control. Once you've met your threshold, identification and action thresholds indicate the pest control is required and preventative methods are no longer effective. IPM programs then evaluate the proper control method, both for effectiveness and risk. Effective, less risky controls are always chosen first. Okay, methods of control. Cultural control, biological control, mechanical and physical controls. Chemical controls. Here's an IPM pyramid. And as you can see at the bottom, prevention is always the biggest, the one you want to use the most extensively and work hardest at. Next comes cultural and sanitation, physical and mechanical, biological, and then of course the top of the pyramid is chemical. And again, even if if it's considered quote chemical or a pesticide, it can also be a very low toxicity form that usually derives from nature in itself. When you're talking about things like deterrents and other things, for instance, bacteria that kill certain insects and that kind of thing. Okay, let's start with cultural. The number one thing is sanitation. If you keep the pesticide, the pathogen or the pest from becoming getting to a foothold in the crop, then you can prevent it from reaching your threshold and damage. And sanitation is a way of doing it. Anything infected, any material that's infected, you get rid of. You handle it properly, keep it away from other crops, other parts of your garden, and don't introduce it back into your composting and that type of thing to reintroduce later on. Proper selected and rotated crops. You want to go in and look for instance, if you have a mosaic problem in your tomatoes, you don't want to next year plant tomatoes back in the same spot. I'm going to show you later a good rotation graphic that'll help you figure out how to do that. Sanitizing and solarizing your soil. For instance, putting plastic over your soil in early spring. Let the sun do the business of actually getting rid of a lot of your weed seed. And it will also, many things can't handle it above temperatures of 130 degrees, I believe 134 degrees. If it gets more than that, then it will kill the pathogen. Choosing the best planting and harvest times, because if you can plant and harvest before the life cycle of the insects, for instance, before the eating part, the larvae usually, and that type of thing, the larvae and the caterpillars or any of the younger parts of their life cycle, you can avoid it altogether because they won't be there. Using resistant varieties of certified plants and taking in advantage of allelopathy and intercropping. And I'll go over those in a minute too. Sanitation is paramount with tools and other equipment, planting materials, containers, media, irrigation water, benches, and growing areas. So, like I said, you wanna always have a wet or a moist towel with a bleach solution in it handy to wipe your tools off, or in my case, I use a 10% bleach solution in a spray bottle and just give everything a spray, especially in between pruning cuts, in particular between a plant that's infected and a plant that's not infected. Planting material, again, you don't want it to come in with the disease on it. So when you're buying if you're buying seedlings, you're buying perennials to go into your either your vegetable garden or your landscape, then you want to make sure they're disease free to begin with. Containers, everybody uses their containers over and over again. You want to make sure you sterilize those before you use them for your next turn of plant material. Your media, obviously, again, it needs to be sterile. Irrigation water, I don't know how many of you have actually dealt with irrigation ditches and that type of thing. I owned a property over there in the Bosque in Albuquerque in Los Ranchos, and we had to be real careful of what the irrigation ditch brought us in the form of either seed or spores or even bacteria that might come from the property above, upstream. And in a lot of cases, if it's coming from well or you're trucking your water in or whatever, it's usually not as big of an issue. But you do have to keep in mind those situations. Weed and dead plant material should be removed so they can't serve as vectors for pests. In other words, there's several that actually part of their lifestyle is lived in that thatch or that mulch that's on the ground. So you want to make sure whatever you have lying around is removed. Dead weeds, because the seed will be in there, and it could be vectors again for certain plants completing their life cycle under the thatch. Now, that's again, we talked about bringing in mulches, but you want to make sure they're sterile mulches, or at least as disease free as possible. Yard waste should be removed from the site and secured in trash bags. That keeps anything that's airborne from floating around. And it also, in black trash bags with a little bit of moisture in those bags in the full sun, again, that is a solarization process that helps kill anything. So the whatever's in those bags can be greatly impacted by the solarization process. Do not compost your yard waste. They say don't compost your yard waste, but I think most people will. Just if it was infested when you made it yard waste, then you want to get rid of it. If you think it's disease free and you haven't noticed, just in your pruning of your roses and your grass clippings and that kind of thing, you hate to just get rid of it. But if you think it's pretty pathogen free, and insect and pest free, go ahead and put it in your compost, because the composting process itself helps to eliminate a lot of those problems. Crop rotation. The principle of crop rotation is to plant a crop in a different location each year. Rotating crops disrupts pathogens, insects, and nematodes, their life cycle, by removing the host required to complete it. Pests may remain in the soil for quite some time, waiting for the required host to be planted. Therefore, a crop should only be grown in the same spot a maximum of once every 3 years, while a 3-year rotation is minimally recommended. A 4 or 5 year rotation is even better at reducing buildup of soil-borne pests. Here's a nice little chart of kind of how you kind of decide what you're going to be planting, and then you put it on this kind of rotation. And Kelly, if you want to, I'll be sure and share this PowerPoint with you, and you can email it to whoever's interested in having it.
Okay.
And then back to soil sanitation, solarization. Soil solarization is a non-chemical method for controlling soil-borne pests using high temperatures produced by capturing radiant energy from the sun. This involves heating the soil up by covering it with clear plastic for 4 to 6 weeks during the hot period of the year, and when the soil will receive the most direct sunlight. Now, I had a question on whether you could use black plastic, and I suppose you can. In fact, it probably is just as effective, if not more, because it will get even warmer under there. And once those little seedlings germinate, there's no light for them to photosynthesize, so they will eventually just die out anyway. So that'll help get the weed seed out of there also. Anywhere where it can get hot direct sun. Plastic tarps allow the sun's radiant energy to be trapped in the soil, heating the top 10 to 18 inches to a temperature lethal to a wide range of stillborn pests, including weeds, plants, pathogens, nematodes, and insects. Time of planting and harvesting. The availability of crop varieties with a range of maturity periods allows considerable flexibility in planting dates. The most common manipulation of planting dates is the utilization of safe dates, which are a range of dates where a given crop can be planted such that it is in a relatively invulnerable stage when the damaging stage of the pest is present. Now, that sounds kind of convoluted, but what that means is you're trying to offset the life cycle of the pest and your crop in order to disallow them to have that advantageous period where they live off, where the pest can utilize the plant for its life cycle advancement. Harvest frequency or scheduling can have major effects on pests, particularly weeds and diseases, but harvest can also be used to mitigate insect infestations. In other words, harvest before the insects get, if it's possible, harvest before the insects can get a foothold in your crop, and that is all part of the planning and timing of your crop itself, which there's a lot of going on these days, is doing your head start seed germination inside long before it's warm enough to plant outside, and that giving you that up to 3 to 4 weeks change in the period of seed to harvest period, which will misalign it from when the most damaging pests are through their cycle to the point where they can damage the plants and your crop. Resistant disease-free varieties. Oops, what did I do? Let's go back to my pyramid and then I can talk about the other stuff. So we talked about cultural and sanitation, keeping everything clean. Then we go to physical and mechanical. Now, physical and mechanical involve actually going in and picking the insects off the plant. Squash bugs is kind of a funny one. Many people say all they do is go in and physically take them and squish them, or squash them, as I say. So that would be a form of physical control. And then the mechanical is going in and pruning out diseased parts of the plant, diseased fruit that has already been infected, but it's on the plant itself. Get rid of the diseased ones and eliminate that kind of thing. Remove whole plants that are infected that are next to other crops, or physically remove the whole crop of that species to prevent it from moving on to other things. So that would be more of a physical kind of control. Not there either. Okay, and then biological control. You're looking at, for instance, things like lace wings that are good for thrips, These are things you can actually go to your nursery and praying mantis. You can go to nursery and buy ladybugs. You can use BT, which is bacillus, is a bacteria that gets into many of the soft body insects that chew and eat on our plants. Things like that can help with biological control. And again, it's something that you can do that doesn't involve using the chemicals. Now, finally, the chemical side of it, we talked about when the last resort kind of thing, when you hit that threshold and the rest of the things aren't working to keep it under that threshold, then you go looking at some of the chemical things. But even within the chemical, what would be classified as chemical control or herbicides, there are a lot of much more safe products out there to use that in many cases can even help with soil amendment and that type of thing. For instance, a diatomaceous earth, something that's good for crawling and soft-bodied insects. This little, I believe they're sea plankton that have fossilized sea plankton that have these little sharp edges on them. And although in our hands it feels like talcum powder, on their little tiny soft bodies, it scrapes and scratches and causes them to completely dehydrate, as it also acts as an absorbent. But that also in turn can go into the soil and help amend your soil for help with pH and that type of thing, and water infiltration. And then there's other things like I mentioned, BT, Bacillus thuringiensis. If Michael, you might be able to help me with that. But it's known in the industry as BT, and it's actually just a bacteria that is a pathogen to many of our pest insects, and it works really well. In addition to that, there is just pyrethrins. Pyrethrins are, although synthetic, they are actually a synthesized product that it's made by certain plants. For instance, marigolds. We didn't talk about companion planting, but that's another thing you can do. Planting interplanting within your food crops, you can put things like marigolds. Marigolds have these naturally occurring deterrents, or they don't, the insects don't like whatever the chemical is that these plants put off. The same thing with citronellas and that type of thing. They are retractants of many of these insects, and so you interplant those. So that's another biological control. But the other thing is that many of these things, as I mentioned, are actually, although they're manufactured and they're made in a laboratory, so to speak, they are naturally occurring in many cases. So the bottom line is that you want to go through and use all of, I didn't speak of allelopathy. Allelopathy is also one, again, with plant material. Allelopathy is a certain plants that actually put off a chemical often in the soil that either prevents things from growing near it, or it actually has a chemical it puts off into the soil that is a deterrent to the soil-borne pathogens. You can do things, for instance, many of the Atriplex, the four-winged saltbush, many oaks and that type of thing. If you'll notice, they're good at keeping things from growing underneath them to starve them of their nutrients and their water. So things just don't germinate in those soils. But you can also, in many cases, plant things that aren't susceptible to those allelopathy chemicals that can grow in there, and so the tree or the plant that has the chemical will deter the pathogens, but it doesn't that are the desired plants that can affect the desired plants, and yet the allelopathy doesn't affect the plants you want to grow there. So it's a song and dance. You really need to research. You need to find out what does well with everything else, and the whole idea of companion planting. Our three sisters are a good example, mostly in structural and in this case symbiosis with the legumes of the beans and the putting nitrogen in the soil, and the squash covering the soil and keeping it cool and preventing evaporation, and then the corn as a lattice for the beans or peas. That's all companion planting. Those all are part of this integrated pest management. And pest doesn't always just mean bugs and funguses. It means a lot of other things are involved in pest management. So anyway, I apologize for the lack of the last half of the not last half, but the last section of the PowerPoint. And if there's any questions, as I mentioned, I'm going to source and find that other one. Kelly will have the copy of the full PowerPoint that she'll share with you if you're interested.
Yeah.
Any questions?
Go ahead and share that with me once you find it. Then I can go ahead and share that on our website. And if anyone on here that wants a copy, then I'm more than happy to email you one.
Okay, great. Any other questions?
Feel free to unmute yourself. Let's see. If there are no other questions, that will conclude our presentation today. Okay. All right. I guess we do not have any questions. I just want to say thank you, Bud. I know I contacted you the last minute, so really appreciate it. So thank you.
Well, I apologize for the mistake with my really got me concerned, because I don't know where else all the rest of that would have gone, but I'll find it. Somebody has it, because I know I've shared it with other people. I might have to ask for it back.
Oh, okay.
So anyway.
All right. Yeah, it might have they might have saved it and deleted some of them. Then
I'm sure I know I had shared it with some of our other agents because they wanted to present it for themselves, and so they've got it. I just have to go find it. I just don't know where it went in my own system, so we'll see.
All
right. Well, thanks.
Okay, thank you, Bud. Really appreciate it.
All right. Bye-bye.
Okay. Well, I am going to release a poll if you guys don't mind. There's only 2 people on here, so if I could get you, George and Michael, to fill out that poll for me, I would really appreciate it. While you do that, I'll just go ahead and share some upcoming information. I do not have it on here, but anyway, so just to let you know that if you are a livestock producer, on September 21st, we're going to have a cattle marketing presentation, and this will be presented by Dr. Gifford. He's coming from New Mexico State University, and he is the beef specialist. So he's going to be providing that cattle marketing presentation for us, coming from the producer side perspective. But starting in this month, we will be shifting from weekly webinars to every other week. So such as for this beginning of September, we started off with integrated pest management, and we're really gearing to get back indoors for workshops, and we're having a pollinating insects at the end of September. So you'll find that information on our website. And just to let you know that we're shifting from weekly webinars to every other week. And thank you all for joining us this evening. All of our information of who we are as a project to what we have as far as upcoming events as educational presentations to our very own conservation planning program that we collaborate with the Dene College Land Grant Office. So if you know any producers in the Eastern and Northern Navajo agencies that need assistance with developing a basic conservation plan, regardless if it's ranching or farming, we're willing to provide our assistance, and this is free of charge. So if you are interested in a workshop or want to do an orientation, or even have just one-on-one tech assistance, let us know. And our email is right there. And this is just a platform of our website. This is the main platform for what you're going to be seeing and our upcoming events tab. Other than that, thank you all for joining us. We're on Facebook, and that all of our webinars are recorded and posted on our YouTube channel, and we will be coming out with our newsletter. So thank you all for joining us, and I hope you have a good rest of your evening. Just to let you guys know, we're part of the Navajo Sustainable Agriculture Project. In short, we're called the NSA Project. We're in a collaborative effort with the main partners is the Dene College Land Grant Office and Community Outreach and Patient Empowerment, which stands for COPE. And we're also partnered with New Mexico Cooperative Extension Service. And we are also funded by the USDA Outreach and Assistance for Native Farmers and Ranchers and Veteran Farmers and Ranchers program. So majority of the time, you see a lot of on our flyers when we post webinars and when we share our in-person workshops, you see their logos as far as the college logo that you see here, and you see COPE and USDA and New Mexico State University. So they all play a big part in our project. But moving on to our main goals of the NSA project is mainly to help producers with their operations, profitability, and sustainability through our educational programs and technical assistance that we provide in the following counties, which is McKinley, San Juan, and Cibola counties. So we get a lot of producers in McKinley and San Juan, which is the northern and eastern agency, especially with our technical assistance as far as help producers develop a conservation plan, really basic for either a rancher or a farmer. And as you know, that we even go as far as providing weekly webinars, presentations, alternating topics each week from farming to livestock and back to crops and livestock and so forth. So we also provide that, and even our project partners tap into our presentations as well. So they normally have, we have COPE, which is Carol Palmer, who provides a lot of gardening side of things and a lot of great presentations and unique ways to make gardening more enjoyable and unique. And we also have some of the team from the Dene College Land Grant Office to provide livestock record keeping to vaccines and so forth. So they provide a lot of that presentations with us too. And we're kind of not drifting, but we're kind of moving towards more having webinars twice a month. So one maybe in the first week, and the second will be in the third week of the month. But so we're only going to have 2 webinars a month, and we're pushing more to get indoors and having land boards or producers or farm boards to let us know that this is what we're looking for, and the NSA project can help out with that. And also, as well as providing USDA resource series, fairs, gathering local field reps from local field office to share what type of programs that local farmers and ranchers can apply for, and making that program more have access, have these folks have access available to these programs. Then lastly, through our gardening programs, is basically to help increase the local production and consumption of fresh fruits and vegetables and healthy foods by families and individuals.